So with that, I'm going to just introduce the next speaker, and that's a more detailed depth of care sharing. It's Johan.
Johan. Okay. Right, so is this on? And that's that. Okay. Okay. Right. See it here. Okay. Okay, there we go. Yeah, so I'm gonna dive in a little deeper on care chain and our plan. And okay, yeah, so I think Stefan already mentioned this problem that we see with the fragmentation of health data. So over 300,000 apps worldwide in different areas, and that's the self-generated health data that we see, that we collect from apps and so on. But the situation is equally bad on the other side, on the hospital system, and there's over 100 electronic health record applications in Stockholm alone. And all these create silos for data, and we miss a huge opportunity here, taking advantage of this data to apply machine learning and AI to discover biomarkers, digital biomarkers, and solutions to a lot of the problems that we face in optimizing our health. So we have a simple plan. Stefan is a rocket science, so we're gonna launch this rocket, and it has 3 steps, and I'm gonna go through the different steps here. So, okay, the first step here, it's the foundational step. We're gonna launch an open blockchain platform for this personal health data. And there you can store both the data you generate yourself and the data you get from your caregivers on the top there. It's interesting to note that the amount of data now, the self-generated data dwarfs that of the doctor-generated data. And we only see that increasing, and the reason why this is interesting, this is the type of data you can apply to get predictive analytics and prescriptive analytics. Once you reach the hospital, it's already too late. You need to capture the data sooner to be able to take advantage of these algorithms. So this is the first step, and we, as Stefan said, we're using Ethereum, or a version of Ethereum that's called Quorum, and it comes out of the Enterprise Ethereum Alliance. And what's interesting about that version of Ethereum is that it has different qualities and more capabilities of managing private transactions. It's not good to have metadata like that I'm contacting the oncology department or something. That could be bad enough. So if I want to do that in this platform, only the parties involved in the transaction will have any data on that. So we're doing this exploration and the early steps together with a few partners. I have more about that later. Yeah. But it's so important to say that this is a consortium, permission blockchain, so it's not open for anyone to join and produce these blocks as miners. We have a select group of trusted partners that does that, and that also means that we don't have to do any mining and proof of work. As you know, it consumes 0.3% of the global energy production on the planet at the moment. So none of that's going to take place in this platform. The next step, once we launched, dropped the fuel cell, of the rocket, is that you need an app to interact with the blockchain. And as you know, a blockchain is a database where everyone has write access to it. It's a bit unusual as a concept. And to be able to interact and do transactions on the blockchain, you need to have your private keys, so you can sign the transactions digitally and place them on the blockchain and make a transaction. These keys have to be managed some way, so they will be stored in a mobile app and in the special chip on the mobile phone these days. They have this secure enclave, which is sort of like the chip you have on your credit card. So if somebody tries to pry it open, it will break. So it's a very, very safe way of managing your private keys. And the way we are doing this, we're creating a new type of digital identity that's self-sovereign. It's not issued by anyone, but you create it yourself. And the digital identity has two parts. It's a unique identifier and then some attributes connected to that identifier. So once you download this app and create the identity, you're born into the world naked. You have this identifier, but nothing connected to it. And the way it works is that you make certain claims on your identity, maybe your name, where you live, phone number, that I have leukemia, or whatever it might be. And these claims are then verified by third parties, maybe my doctor that gave me this diagnosis. And so you get more and more of this, and your identity is then built up over time. And this type of identity is now being standardized in identity.foundation. Collaboration with a lot of startups and open source communities within the blockchain space, but spearheaded by Microsoft, and IBM is there, Accenture, and some other big companies. And it's also done together with the United Nations, that has this as one of their sustainability goals, 16.4, saying that nobody on this planet should be born without a digital identity. So they're hoping to have this solved by 2020. So this is a very core concept to us here. And here you can then use this. So this is not only the identity to sign transactions, it's also an app to manage that data, the attributes, the claims that you have. The way it works, the user experience is very similar to mobile bank ID. So when you sign a transaction, you will be sent over to this app and place your fingerprint there or the PIN code. The difference is that with this solution, you can manage all your data, not just your name and your personnummer. Yeah. So the data will be stored primarily on your mobile phone, and then you can use secondary storage, especially when you want to share the data with a third party. But the basis of this is that it's stored on your mobile phone. So this is a little sketch over how it would work. So we already know we have two types of data, hospital data and self-generated. Just a few months ago, Apple announced a solution in the US. They have 39 different caregivers and 1,000 hospitals. It's hospitals like Johns Hopkins in Baltimore, and what they did there is that they use a special format. It's called HL7 FIRE to send complete electronic health records from the hospital directly to the mobile phone. with no intermediary involved in this process. And this was possible, and it complies with all the privacy laws in the US. And it's such a simple solution, and so that's how we are going to build this as well. You can have no intermediary when you do this handover of data that you're exporting for legal reasons. But once it reaches your phone, you would also have like a backup of the data somewhere else in the cloud. It's called the Identity Hub Protocol, so that the Microsoft Cloud would be one place where we could put that, or anywhere else. Yeah, so then what happens is we take this data, we compute some metadata about it, and publish a hash to the blockchain. And then when I want to share the data, I will send it directly from my phone to the receiver's phone using some kind of peer-to-peer protocol. And the hash is then used to verify the integrity of the data, that it hasn't been changed. Sometimes maybe this model doesn't work. Some organizations might need my data to do some other kind of processing, and then we still need to rely on the old paradigm of computing, and then we need to provide a consent for data processing. But we will store that the same way. Another way to go about it is to use a delegation protocol, so I can delegate write access to my database to some other app. And this is a bit different than what we're used to with social media and Facebook and so on. Then we sometimes delegate read access, but here you can delegate write access to the database as well. Of course, you should be able to revoke any consents given, and that's fully under your own control. And then we're also using it for distributed machine learning, where we train machine learning models on the phones and then later aggregate it to a full model. Yeah, so this creates then, going into some of the applications, how we're going to use this. And this is the third step of this rocket. So it will be an innovation platform where individuals that come to use any of these 300,000 apps will come with all their data already aggregated. So you can only apply an algorithm on top of that to provide some service. The other thing is that we want to have a network of self-sovereign data owners that we can query to participate in training these machine learning models without seeing the data. And this is important. So, for instance, a typical machine learning model that you have in research is to train a computer to recognize if there's a cat in an image. And you let it see 1 million images, and then it gets really good at it using deep learning. In this scenario, we would send that model, and it could see my whole photo library and train and set the parameters of this deep learning network. But the one creating the model would never see any of my pictures. And imagine how that translates into the health scenario. And then once the model is trained, you can use it and for your own purposes. And this is another scenario that comes in here, and we call it impact tokens. So you could incentivize desirable behavior in this network. At the foundation, we have the blockchain. We have some partners running the mining nodes. They will be incentivized with a coin. But then maybe a pharmaceutical company or academic organization want to train a model. So they will send it out to all these mobile phones. The training happens on the mobile phone. I get some parameters, a subset of parameters. And then we collect all of those from all those mobile phones, and we pay accordingly how much they contribute to the model. And then you aggregate that in the cloud, and you have a model that you can then deploy and sell to the network. Another application here is health as a service. We see that we need more than just a cure or a pill. So we can see this kind of network happening here. Not going to talk in detail, but here, this is an example then. So we have war on cancer for the community. We have insurance companies and different healthcare providers. I'm going to hurry up. Maybe I can't get into this. I'm over time, but this is really the elephant in the room. And we've seen how it hit Hälsa för mig and in Uppsala also, the journal online. They did not allow this to happen. And the reason being is that a public agency like E-hälsomyndigheten, they run errands or open errands, and they are under a special legislation. You cannot share the data while this happens. It has to be concluded before you can share the data. I'm sorry. How important is it with the minutes? But yeah. So, anyways, the way we are solving it is that you need a legal digital identity, so that it's clear that when somebody gives you the information, you enter into a legal agreement implemented in a smart contract or Ricardian contract, as they're called. You can look that up. Then it's different. And you need to stay in the domestic property law. And my mobile phone is within my jurisdiction. So if you send something there, I really own it. You need a warrant to search my mobile phone. Yeah, so that's that. But remember this, the intent of GDPR is to give back control over the data. And if you happen to have a hash that's in some way connected to your data and you cannot erase that from the blockchain, what's the big deal, I would say. And there's also technical implementations. We can hash the data, add a random number, a so-called salt, and then we hash that and put that in the blockchain. So then you've solved it with another level of indirection. And maybe you should issue a warning before using any of these systems, just as you should for the World Wide Web. Anything you put out there, you can never take back. Yep, so infrastructure, identity, a little legal work, and then we can realize this marketplace of wisdom and machine learning models. We're working with some partners, Karolinska, Stockholm University, and Merck as the pharmaceutical company, with some projects, and we would like to invite all of you to join this initiative and be a part of running this network with us in a consortium form. So that's that. Okay. 3 minutes too much. Okay.